Hello and welcome to the lecture. So, in this lecture, we are going to further study about what is the modern concept of covalent bonding. Now, for understanding how covalent bond can be explained, there are two theories which will help us to explain actually what covalent bond is. And the first theory is Valence Bond Theory, and the second is Molecular Orbital Theory. Molecular Orbital Theory. So, first of all, we will look at the Valence Bond Theory. What are its advantages? What are its postulates? And we will look how it explains the covalent bonding in the molecules and what are its limitations. And after that, we will study about actually how molecular orbital theory it explains the limitations that are posed by valence bond theory. So let us start with valence bond theory. Now the valence bond theory, the main points of this theory are that a covalent bond is formed by overlapping of atomic orbitals of valence shell of the two atoms. So what it means? So it states that when the two atoms they try to form the covalent bond, then the valence orbitals they overlap. That is, there is the concept of overlapping. So the first main point of this theory is that when overlapping happens between atomic orbitals, and the atomic orbitals they should be of valence shell. Or we can say that outermost orbitals. So the outermost orbitals, what they do, they overlap in order to form the covalent bond. Now there are overlapping is of two types. Overlapping it happens either by head-on overlap, or it may happen by sideways overlap. Now, when there is an headway overlap, what happens is that sigma bond is formed. And when there is sideways overlapping, then pi bond is formed. So first of all, we will look how head-on overlap occurs, that is how actually sigma bond is formed, and then we will look how pi bond is formed, or we can say that how sideways overlap it occurs. Now first of all, when there is an headway overlap, a sigma bond is formed. So it means that overlap it is okay, that is when there occurs sideways overlapping between orbitals, or we can say that end-on-end overlap occurs, then formation of sigma bond is formed. Now this type of head-on overlap it occurs usually by three types. Or we can say that head-on overlapping it occurs usually of three types. First overlapping, it is SS type of overlapping. So let us look how SS overlapping occurs, and for this we will take the example of formation of hydrogen molecule. Now as we know that hydrogen it is having electronic configuration of 1s1. Similarly, when another hydrogen having same electronic configuration of 1s1. Now this hydrogen it is having one electron, it is outermost shell, and this hydrogen having also one electron in its outermost shell. Now what happens is that this is an s orbital. As we know that s orbital, it is spherical in shape. It is spherical in shape. Spherical in shape. Now what happens is that suppose this is hydrogen 1 and this is hydrogen H. Let us represent this as H1 and this as H2. Now what happens next is that as these two s orbitals, they come close to each other. As they come close to each other, so what happens is that overlapping occurs. Overlapping occurs, as you can see here, overlapping occurs between orbital. And this, since this is the overlapping, this is head-on overlapping. This is head-on overlapping. So whenever there occurs overlapping, according to valence bond theory, covalent bond is formed. So when overlapping occurs between one s1 of one hydrogen and one s1 of another hydrogen, what happens is that covalent bond is being formed. Covalent bond is formed. So if I represent this in terms of molecular orbitals, this orbital is being generated overall, since this is one hydrogen molecule and this is another hydrogen atom. So as a result of which a covalent bond is being formed between hydrogen 1 and hydrogen 2. So whenever there occurs an ss orbital, a single covalent bond is formed, and this single covalent bond, it occurs. Why? Because an ss overlapping happens. Ss overlapping happens. So I have represented this diagrammatically here. So this is hydrogen 1. It is having spin of up spin like this, and this hydrogen, it is having down spin. So when overlapping happens, so this type of orbital is being generated, so like this, having opposite spins. So in a molecular, what happens is that whenever there occurs head-on overlapping, in case of hydrogen, overlapping between ss orbital happens, as a result of which a covalent bond is being formed. So this type of overlap, this is called as ss overlapping. ss or overlapping. So this is an example formation of hydrogen molecule. It is an example of ss overlapping. Now there is another type of overlapping, and it is called as sp overlapping. sp